So we're going to get started. Welcome, everybody. This is session 5, Drivers for Novel Technologies and Current Needs. If that is not what you were looking for, you were in the wrong room. I am your moderator, Corinne Scown. So I come from Lawrence Berkeley National Lab. I'm a staff scientist there, joint appointment at UC Berkeley, and I'm a life cycle assessment and techno-economic analysis person. I'm really excited to moderate this panel. We have some fabulous panelists. So I'll do quick introductions for each of them, and then they'll kind of rotate through their individual presentations, and we'll kind of do Q&A and discussion as we go along. So first, we've got Forrest Etter. Raise your hand. He is the Director of Design and Construction Innovation at Prologis, where he leads a central team within the global development business tasked with standardizing designs and best practices, incubating and scaling innovative ideas, and implementing strategies to reduce embodied carbon across all new development projects. We've got Nick Santero. Nick was my office mate in grad school. He leads the sustainability science team at Rivian and has been tackling sustainability for over 15 years with a focus on life cycle assessment strategies to influence product design. Prior to being at Rivian, Nick was at Apple. And he led the technical development of Apple's 2030 climate neutrality plan. He's also been a lecturer at UC Berkeley and is just a really fun guy to share an office with, I have to be honest. Okay. We've got Birgitte Dodd. Excellent. Birgitte is a research ecologist in the energy branch at the U.S. Army Corps of Engineers Research and Development Center at the Construction Engineering Research Laboratory in Champaign, Illinois. So she had to make a trip. Her work includes research and application of sustainable technology and process solutions to support Army and DoD resilience requirements. She's got more than 20 years of experience leading strategic sustainability planning and solutions application. Really, really incredible. And last but not least, Priya Chhiba from Google. So Priya is the sustainability lead for data center innovation at Google's Advanced Technology and Innovation team, where she's responsible for the incubation of the new data center technologies that are sustainability focused and support Google's net zero by 2030 target. Her responsibilities include the incubation of solutions associated with the reduction of emissions across all 3 scopes: water and cooling, sustainability, and energy efficiency. And before coming to Google, she spent 2 decades in power generation and started her career working at a power plant, a coal power plant in South Africa. Wow, we'll have to ask her about that. Okay, so with that, we are gonna start with presentations. And first up, sorry, I should have gone through these pictures, but you can see our people. So Forrest, you're up first. Everybody else can take a seat.
Well, thank you all so much for coming today. My name is Forrest Etter. I work at Prologis. I'm based out of Denver. I'm really thrilled to be here today talking to you about net zero and how we're reducing embodied carbon through our warehouses at Prologis. So really want to start quickly with an intro to Prologis, because probably most folks in the room haven't heard of Prologis. We are the world's largest industrial real estate developer. A lot of big stats on this list: 1.2 billion square feet of real estate around the globe. We develop around 30 million square feet of real estate a year, about 50 million square feet of pavement a year. So we use a lot of materials in our construction and development. We're essentially a giant landlord. Many of our customers you've heard of, folks like Amazon, Wayfair, Target, DHL. Around 3% of the world's GDP flows through our distribution centers, which is a very fun fact. But really, I think all these numbers and these scales show that we have a massive global footprint that we can leverage our scale and try and do good in the world, but it also translates into a massive challenge when we're trying to decarbonize our physical portfolio of buildings. Our net zero commitment is based on science-based targets. We are trying to be net zero by 2040, not quite as ambitious as Google, but I would say still fairly ambitious out there. We started this journey back in 2022 when we made these commitments. By 2025, we hope to be carbon neutral for operations, primarily through the use of high-quality offsets and permanent removables. We hope to, by next year, be the world's largest producer of on-site solar generation. So that is the benefit of having 1.2 billion square feet of rooftops around the world, is leveraging solar the best that we can. Net zero in operations by 2030. And then, of course, the big one, net zero across our value chain, including scope 3, which is about 99% of our entire emissions by 2040. So that is really the bulk of my focus. And as a group, reducing embodied carbon specifically, which we'll dive into a little bit more right now. So looking at Prologis' scope 3 breakdown, 75% is customer energy use, is predominantly through HVAC, and I think you'll hear a lot of the common things today with many of these speakers. 25% of our scope 3 emissions comes from construction and development. So we're talking about the physical materials that we're putting into our buildings. This is where I see the most opportunity for innovation in the space and where we really had the least amount of investment in my mind. Our customer energy use, that can come through electrification. That's really the easier problem to solve, not that it is all that much easier. But the 25% for construction and development, we still need to build buildings. We need physical materials, to generate more warehouses every year. We don't yet have the solutions available to us to be able to deploy at scale in order to meet those needs and overall achieve that 2040 goal. Something that we started doing last year and will continue moving forward is completing life cycle assessments across all of our warehouses. So that's about 70 buildings a year or so that we build. We're really generating an amazing database or nutrition label of what is getting put into our buildings. This is from some data from Branch Pattern, who's one of our lead sustainability consultants, on the average embodied carbon for a warehouse project. Spoiler alert, it is all concrete. Basically 50% of our buildings are concrete. We use them in our walls, our slab, our pavement, our foundations. The rest is steel. So concrete is by far the biggest offender at Prologis and of course around the world. So much of my work focuses on concrete specifically. Much of the rest of Prologis, including our corporate ventures team, is making strategic investments into concrete-related startups and companies, all with the desire to reduce this overall GHG emissions from our concrete down to zero, ideally. So I'm gonna end with last slide, thinking specifically about concrete. Big area of focus for me, of course, so I lead a team. We focus on new innovations in the industry, working to research, pilot, and then ultimately deploy solutions across our global portfolio that help us to reduce that embodied carbon footprint. So we have a big focus on concrete because it is 50% of our total emissions factor. So we really try to look at this holistically and on each project, think about 6 different ways that we can potentially reduce the greenhouse gas emissions. The first is a design improvement. So how do we build more with less? There's many different interesting market standards that Prologis has to abide by that aren't really based in science, something like the thickness of our floor slabs. It is traditional in California markets to pour a really thick floor slab, like 9 inches thick of concrete. Where did that come from? Who knows? We've been doing it the same way for 30 years, and there's a perception in the industry that more concrete is better. It's a more higher performing building, which is just not true. In advances in concrete, there's absolutely a way to build more with less. We can go to a 6-inch slab as an example. You're saving 30% of the GHG emissions from your slab right then and there. So working on ways to incrementally improve our designs, to use less material while still maintaining the same performance of our buildings. That's a really big one, sort of low-hanging fruit for what we can do right now. Reducing OPC content in concrete mixes. This is another pretty industry standard, I would say at this point, using supplemental or cementitious materials. We're experimenting with some brand new ones on the market, like a company called Positive on the East Coast that uses ground municipal glass from New York City as a cement replacement, up to 70% cement replacement. We've tested that on a couple of projects, so that's a big one for us. Using novel cement. There are at least a dozen new startups I can think of in the US and abroad that are creating an alternative type of Portland cement from basalt or using electrolysis instead of a thermal reaction to make Portland cement. So we're looking to invest in some of those companies, pilot them at small scale, low risk applications like sidewalks and foundations, determine viability, and then move forward with scaling them across our portfolio. Number 4, why not even use, just don't even use the concrete, use something else. So that could be mass timber is another really big technology that we're looking at. Thinking through asphalt versus concrete in terms of that 60-year life cycle reference study period, which one is actually better for the environment in the long run? How do we optimize the use of different materials that aren't concrete? Number 7, carbon capture, utilization, and storage. Not something that Prologis is doing specifically, but partnering with incumbents in the space that are utilizing that technology, of course, reflects in the EPD of that particular type of mix, and it really helps us with our goals. And then lastly, incremental process improvements. So this is part of our big procurement strategy. It's really highlighting those concrete suppliers in the industry that are trying to make improvements, such as using green energy to power their cement production or something like that. And really partnering with them to make sure that we're having great clean data that goes into our projects as a way to ensure that we're reducing what we say we're reducing. That's it for me. Thank you so much.
Well done. You stayed at 6 minutes, I think. So we were told 6 minutes. Shall see. Okay, I'm gonna show you more pretty pictures. I think that's my goal today. So I'm from Rivian. For those of you who don't know Rivian, we make cars and trucks, and we make vans as well. They're all electric, which is pretty exciting. The reason I came to Rivian is because I couldn't think of a much harder thing to make than an electric car. Turns out I was right. It's very hard, and I'm constantly humbled by how hard it is to make something that works. Just the fitments, if you go back to your car, look at the doors and look how close they align together. When you shut your door, nobody thinks about it. I think about it a lot now. And it's amazing how tight those tolerances are, and then you have to do it over and over and over and over again. And then we think about quality and making a car that somebody wants. It's not just about making something that somebody can afford, but they want to stay in that car and they want to believe in that car. And I've been humbled in my 3 years at Rivian, kind of learning about this space and understanding that. I think if you ask 100 people at Rivian what the company is and what the strategy is and why we're here, you're gonna get 100 different answers. And for me, I think that what Rivian does is it tries to electrify a really difficult market segment. Cars and trucks, SUVs and trucks, vans. These are heavy, heavy, big things. Rivian was the first pickup truck to market, electrified pickup truck to market. And that's saying something. And we can argue it's really heavy. It's like 7,000 pounds. That's really, really heavy. You can argue maybe we don't need as many trucks, maybe we don't need as many SUVs. Those are fair arguments. But regardless, the market segment that's out there and the thing that we need to do to decarbonize is try to figure out how do we change not just the behavior of people, but actual things that they're using as well. When I think about Rivian, we're trying to tackle this really hard thing, which is electrifying this difficult to move segment. With that in mind, I was brought on about 3 years ago. And the first thing when I got here, I said, we have no idea what our impact is. What you're seeing here is a breakdown of what our carbon footprint looks like for our R1T. We have an R1T, which is our truck, and we have an R1S, which is our SUV, and you'll hear the words EDV for electric delivery van, which is Amazon drives around and actually delivers packages using that, which is wonderful. Here's what that breakdown looks like. Back in January of this year, we were able to publish our first carbon footprints based on life cycle assessment. So they're out there in the public now. We've got 5 vehicle footprints out there, and we've got methodology reports. And for anybody that's gone to the trouble of writing these reports and getting them reviews and having the models, you understand how long of a process that is. Again, I've been at Rivian for 3 years, and it took me about 30 minutes when I got there to say, we need these, and we finally got them out. And that's because of the rigor and understanding all the information and understanding that data that goes into that is incredibly hard and important. But even doing the math is maybe some of the easy part, because then you start talking to your communications department, and they say, why would we possibly tell the world what the carbon footprint of our stuff is? And you start to have to bring these people along and say, well, why would we say all the bad when we really want to talk about the good? And to my point, this is not bad. These are all opportunities that we see up there. All these breakdowns, I look at steel and other materials and plastics and say, man, it doesn't need to look like this. We can bring all this down. The total footprint's around 400 grams of carbon dioxide equivalents per mile. If you put that out over 155,000 miles, we're looking at something around 60 tons of carbon over that amount of time. I'm not going to compare to ICE vehicles. I can. I've done lots of work on that. But the fact is, if we just look at that in and of itself as the problem that we're looking at, that's a ton of opportunity. We have 60 tons of carbon to work with. The challenge is figuring out what do we do with all of that? Because the math is relatively straightforward. The solutions are so much harder. Let's take steel. We've been making steel for a long time in this world. Very easy for me to go to a supplier and say, hey, give me your green steel. Give me your recycled content. Use renewable energy. And frankly, all those are wonderful ideas. But actually implementing those into a vehicle, making those doors close right, making sure that paint looks just right, those are really hard problems to solve. And so as a sustainability engineer, which I kind of fancy myself as, what I really need to be is an automotive engineer. I need to be a comms expert. I need to be a brand identifier. I need to understand all of the problems that everyone else has so that I can come up with what those solutions look like. That's what I spend my time doing. And those are the real challenges that we have. This is what a model might look like for us. So I am kind of an LCA nerd when I get back to it. I was an office mate with Corinne. We spent a lot of time working on this stuff. And so I love building these models. And I wish I could spend more time doing this type of work. But when I think about building a model, I have to think about what the end looks like. Because if I don't build in the understanding of a particular variable, then I'm not going to be able to understand the impact of that. We look just at charging. That's our operations. That's all the electricity that goes into there. And I think it said on the last slide, about 43% of our footprint is associated with the electricity. But there's so many things that go into that. What's a grid going to look like in 10 years? You know, I don't know. It's really hard, but it's not going to be the same. So we have to do some sort of projections around what that looks like. We have to understand how long our vehicle is supposed to last. We have to understand what things are going to break down. Where are we selling this? What's the range of our vehicle? How's that going to change? And then it turns out that electric vehicles have this funky thing that happens that when overnight loses a little bit of electricity. It's not great, it's not wonderful, every electric vehicle has it, but can we figure out ways to make that a little bit better? This idea of passive drain loss. These are all opportunities for us. We have to build that in when we're thinking about models at the very beginning. So just a month ago, we announced everything on the right-hand side there, which is our R2, R3, and R3X. Now, for a company like Rivian that is essentially just a startup, this is huge for us. Those vehicles on our left-hand side, R1Ts, those run about 70 to 90,000 or even more, a lot of money. And so when we're talking about trying to decarbonize and trying to move that electrification and move that needle, we need to not just think about those premium segments, we really want to get into those other segments as well and start to get this into the more of the populace out there. And this is what Rivian's working really hard on. For me, this is the opportunity. It's not the things that we have out there right now. Those are opportunities and we should focus on them. This is where we can start from scratch, that blank piece of paper, and say, what do we want to do a little bit differently? How do we actually embed all of these new ideas, these new technologies in a meaningful way, meeting all the cost targets, meeting all the manufacturing and cosmetic targets? So that's the challenge. Everything on the right-hand side, that's what I spend my days and nights thinking about. What do I do about these vehicles, and how do I make them as good as possible? This is a terrible slide because it's got way too many words on it. But these are what I think about as far as the philosophies that go into it. We've got 7 sustainable design principles. I'm not going to read them off. But last week, I was at an architectural engineering conference. Don't ask me why. It was fun. I was on a panel. But someone came up to me afterwards, and I showed a similar slide, and they said, Nick, these are not sustainable design principles. These are just design principles. I thought, yeah, that's amazing, because that's where we want to hit. We can't have sustainable design. It can't be separate from regular design. It can't be different from engineering. It has to resonate. So we talk about simplicity and reducing mass and creating sustainable supply chains, or just good supply chains. This is just good business practice. This is how we go about designing things. And the more we can take out sustainability as being this afterthought and this thing that we do instead of everything else, or it's additional or it costs more, we have to break those paradigms. And so my job essentially is, how do we do that? How do we break all those paradigms and really stick this into the actions that we have today? More pretty pictures. All right, thank you.
Hi, I'm Birgitte Dodd. I'm with the U.S. Army Corps of Engineers. I'm with ERDIC Searle to throw out acronyms. I'm going to try and keep those acronyms to a minimum here, even though I'm a government employee now. So ERDIC Searle, the Engineering Research Engineering Research Design Center, and then Searle Construction Engineering Research Laboratory. A bit of a mouthful there. In sitting in on all the sessions this morning and having lots of conversations with folks, I almost feel like I should just get up here and say ditto. Simply because there's so much rich conversation, and as people have been talking, they've been saying so much of what I've been researching, what my colleagues have been researching, what we've been partnering with other organizations to research and to talk about. However, I did put together a couple of slides here, so I will go ahead and speak to them. A couple of definitions and drivers here. I think we all know mitigation, we all know sustainability, just making sure I've got the right slide here. I put these here simply as a reference and as a framework for how the military perceives and looks at mitigation and the distinction between mitigation and sustainability. So mitigation, we're looking at our greenhouse gas emissions, reducing those in terms of how we're changing our operations and how we approach achieving our mission, and then sustainability, using that lens, that holistic, broader lens to determine our targets, where we're going and how we get there. Policies and drivers, we're the government. We got lots of them. We've heard about the executive order, I think in several of the sessions already this morning. So this is really right now our big bogey for greenhouse gas emissions is Executive Order 15057, or what we're calling Buy Clean. We are not as ambitious as Google, but we're big, and we're trying to get there, right? So we've got our net zero goal here to get there by 2040, I think it's 2045, and then we're backcasting. And within each of the agencies, we have set our own targets and our own goals and backcasting there so that we don't roll into 2045 and say, oh, shit. So within 10 years, where are we going to be? Within 5 years, where are we going to be? And then and being able to judge where our progress is going. So in order to respond to that executive order, we get these big, lofty executive orders, and then agency by agency, we are trying to figure out, well, how do we get there? So we've got lots of plans, again, as we're kind of trickling down to the Department of Defense, to Department of Army. We've got our climate strategies, and we've got our implementation plans to guide us in terms of getting again, back to the executive order. The executive order is really broken out into focus areas, and we're looking at our energy and our emissions as one of the big drivers, of course. We've got our net zero goals there. We're looking at increasing our energy efficiency. Where are we getting our power from? What does that look like? What are we doing with our existing buildings, facilities? Again, federal government has a vast array of real property to manage. To Nick's point of why does he work for Rivian? When I hopped on board with the federal government, what was I doing? Hopping on board with the federal government, doing sustainability work. It's a massive, massive challenge. It's a massive undertaking. 841 billion is a number I'm going to throw out, right? We've heard a lot of numbers today. Any hands on what that number means? Government purchasing, and the man gets a gold medal. Yes. So the DoD spends $841 billion a year, or that's what they were budgeted last year. This fiscal year might be different. It's a lot of money, and it's not just for that one wrench, right, that NASA's using. We are responsible for a tremendous amount of taxpayer dollars, and how we use that, obviously. We want to use that not just in a way that's efficient and helps DoD meet its mission. The idea behind this executive order is that it will be a catalyst for how the commercial sector operates. So big financial responsibility, again, for how we manage our facilities, for how we manage our operations, but also using those resources in a way that can then have an influence on how the commercial sector operates. I won't go through all of these for the sake of time, and you have these slides. More numbers, lots of information here. You'll have these slides. This is really a breakdown of those various policies as well as the metrics that will help drive our direction of our, not just our operations, but our continued research and our efforts to understand really how we are going to achieve these targets. One thing to really note here are the key metrics. So we have these targets and we have these goals, but like any organization, we also need to be accountable. So we need to recognize where we are at, and obviously to identify where we're at, we need to have our metrics so that we can measure where we're going. Where are we going? That's the question. So we get our policy, right? And we're told to go forth, to plan, to execute. And we all sit around and we stare at like spaghetti charts and our strategies. And we are trying to unravel, what do these targets mean? So are we looking at net zero materials? Are we looking at net zero projects? Are we looking at a net zero nation? What exactly does that mean? And how do we arrive at that target? We've seen several roadmaps and heard about lots of different approaches here. Definitely a nod to DOE. When I saw their roadmap pop up, took a quick picture. I'm going to be taking that back to my colleagues and integrating that. And that's part of what we do. So at the Corps of Engineers, again, I'm with a research laboratory. And really, our mission and what we do is taking and understanding the policy and direction that we get and bringing that to Army installations and to various Army operations. And partnering is a massive component of that. So I was talking to Priya when we first sat down about some of our strategies for when we first begin to get curiosity over a technology that we might want to apply to our organization. The first thing we do is we go and we look at the private sector. We look at maybe academia for her, she does the private sector. We look at academia. We look at other countries. So what's being done? What's out there? That's the beauty of where we're at today. So what we've come up with is a very multifaceted approach to our research. We are looking at, first putting together our own strategy and our coordination. We're focusing, we've heard a lot about this today, some of these areas. We're looking at, low greenhouse gas emission materials. We identify our hotspots, and I think any organization does this when they're first getting their targets. What are your areas of greatest impact? So for the Corps of Engineers, we're building a ton of facilities. So we're looking at concrete. We're looking at replacement materials such as mass timber. We're looking at asphalt. How do we use that? And we've heard a bit about that today. Research that's being done. And then not just material substitution, right? So we're looking at LCAs. We're looking at, where do we get these materials from? How are they manufactured? We're looking at every aspect. Does it make more sense to substitute a material, or does it make more sense to recycle the materials that you've already used and feed it back into a second life? Then once we have that information, the next critical component is our specifications, right? So we've also heard quite a bit about having prescriptive versus performance. And I'll talk a little bit about that later, but that's really key for us. So, you get these prescriptions of we need to have, X weight of a material. Well, does that really make sense in the grand scheme of things? So changing those specifications, changing those standards, lots of good government speak for being able to make it happen once we can identify using different products. And then fielding studies and getting or transitioning that information out into the field and actually in the hands of the users. So LCAs, EPDs, we've heard a lot about these today. I won't belabor them except to say that if we don't understand what our overall impacts are, we are not going to be effective in truly making our changes. So LCAs are important, particularly from the construction side of things, because we can better understand, again, what are our hotspots? What are the areas of most significant impact within our facilities that we need to look at changing? And then we need to be able to run our numbers and identify what we're achieving by changing the way we're doing things, whether it's a material substitution or a difference in the process. We've been doing some research on whole building LCAs, and there are a lot out there. These have been developed for the past couple of decades, and we are looking at Athena and SEMA-Pro and One-Click LCA and TallyCat, and every LCA has kind of a different structure to it and different data, right? And your end result is only as good as the data that's in the LCA. So right now we are doing some demonstrations on a handful of LCAs that we've identified as being the most applicable for military construction. And hopefully we'll be able to come up with some good results on those LCAs that kind of rise to the top, both in terms of which ones are most effective, giving us the best results, but also tying them into the user. So not to belabor the bureaucratic element of what we do, but is this something that contractors can readily use? Are these LCAs that our staff can have access to? We've got security requirements, all that good stuff. So we're looking at what LCAs would be something that we can feed into our workflow and be used regularly so that we can identify what our impacts are. Concrete, we are like many other construction-oriented organizations. We use a ton of it. And I think Sabi brought up this morning that concrete is the second most emission contributor next to water within the construction world. So we've got some partnering that's going on. UC Davis is looking at developing a model on sequestration so that we can better understand what a second life would look like for concrete. Hit Sabi up if you've got more detailed questions than that. But bottom line is we're looking at like replacement, partial replacement within our concrete. And there are just lots of factors involved to include, does it change a mix design? What do we need to do in regards to our evaluation and testing methods? Looking at all of the factors, also to include if materials aren't located close to our construction site, does it make sense then to use those replacement materials? So again, using it through the lens of that holistic life cycle assessment. Bio-based materials, another aspect or another area that we are looking into. Again, really trying to understand what's available, both in the commercial sector or really readily available right off the shelf, as well as within R&D that can be integrated directly into MilCon. An example here would be mass timber. So we have a research project. We're actually working with several stakeholder organizations in different areas of mass timber. One of our projects being with the University of Washington, so looking at innovative wood products and developing an LCA model, both looking at what's already out there with LCA and potentially having them develop a model to really, again, kind of back up here and look at everything from the forest industry and what those carbon emissions look like all the way into using the materials. We're partnering with an NGO to look at and research what some of the impacts are of mass timber, such as insect damage, molds, and fire resistance. So again, a lot of our standards drive what materials we can replace. Asphalt, another area where I want to say ditto. We've heard quite a bit about it already today. We've got some research going on. Really, three main areas that we're focusing on. One being recycled asphalt pavement. Currently, I think a typical percentage of asphalt recycling that's acceptable is 20%. Some states are pushing that up to 45%. We're doing some testing there because we know that using recycled asphalts can make the pavement less flexible, and that can degrade the longevity of its use. And again, with that whole life cycle analysis, sometimes it makes more sense to do your preventative maintenance and to be able to continue the use of something as opposed to doing some substitution and then having to replace it. Recycled plastic material to replace petroleum-based asphalt as a binder. That's another area that we're looking into. And using bio-based materials to increase the ductilities of top layers of asphalt, again, prolonging its life. So lots of projects, lots of research. Again, pointing back to that spaghetti diagram, we are still trying to crack this nut and figure it all out, and I'm excited to be here and keep learning from you all. Thank you.
not plugged in the right way.
Actually plug it in, try this. Yeah, thank you. Let's try
Okay.
different.
Yep.
All right.
Success.
We have success, ladies and gentlemen. Oops. That's quite all right. I'll grab that.
Trust a tech company to have technical issues. Thank you all for having me present to you today. So I'm really proud about what Google has achieved to date and where we are headed. Since 2007, we've been carbon neutral. And in 2017, we were able to match 100% of our power that we used with renewable energy. Now, that's not enough for us. We want to take this further. So we aim by 2030 to run on 24/7 carbon-free energy all the time. So this is when the sun doesn't shine and the wind doesn't blow. And that's where we are focusing our efforts on today. Additionally, water is really important to us. We use a lot of water in our operations, and we want to replenish 120% of the water that we use. We do that by focusing on watershed health, working with the communities that we operate in, and also supporting or managing the water that we use, so being responsible with our resources. Additionally, we want to be net zero by 2030 as well, as a few of you have mentioned before, and as Corinne has mentioned in my bio. So how are we going to get there? We are advancing carbon-free energy across our operations. We want to reduce emissions across our entire value chain. And then we want to address residual emissions through carbon capture technologies and solutions. So the chart on the left shows our renewable energy matching that we've done over the past 6 years. And as you can see, we've matched 100% of our renewable energy, and we aim to continually do that. On the right, you see our Belgian data center. That was the first site to have solar power. And there we installed 10,665 solar panels. That took a considerable percentage of our power off the grid. We also recently installed batteries at that site to provide battery backup for our data center. At the bottom, you see our collaboration with Fervo Energy, and that's currently utilizing advanced next-generation geothermal to power our data centers in Nevada. Recently, we want to continue supporting advanced clean energy technologies. And recently, we announced a collaboration with Microsoft and Nucor, where we want to aggregate our energy use. And we want to use this to scale clean energy, such as long-duration energy storage, hydrogen, nuclear, and next-generation geothermal. We're also reducing our emissions across our facilities. And green concrete, as a lot of my co-panelists talked about, is one of our major, it's the low-hanging fruit. It's something that we can decarbonize pretty quickly. Once again, we are collaborating with our partners, Amazon, Google, Meta, and Microsoft. And last year, we published a call to action where we set some pretty audacious targets to reach. We are working on these, and this year we plan on doing a joint POC where we want to de-risk the application of green concrete on our data center floor. So that is something that we're working on. We're also focusing on repurposing existing facilities, including office facilities and data center facilities. So here on the right, you see an example of our data center in Finland, where we repurposed a paper mall into a data center. So that was quite an achievement for us. We really believe that we can be impactful through collaboration. We recently launched the Net Zero Innovation Hub in Denmark. Once again, this is a collaboration with Danfoss, Google, Microsoft, Schneider, and a few others. And we want to continue collaborating to reduce our emissions across all three scopes. Open Compute Project is an industry group that we participate in. I currently lead the data center facility sustainability group within that organization. Someone earlier on asked me, hey, what is your organization for digital infrastructure? This is it. This is where we come together, and sustainability is one of the major tenets of this organization. We reduce emissions through improving our energy efficiency. And those data points at the top are pretty impressive. So even though we had more computing done, 550% more computing done within all cloud data centers, not just Google, all cloud data centers between 2010 and 2018, the overall energy consumed was only 6%. On the bottom, you see Google's power usage effectiveness. And as you can see, that's an indication of efficiently using our power. And as you can see, Google's has continuously declined over the last few years. That's something we pay a lot of attention to. We still believe there's a lot to be gained in terms of energy efficiency. And that I saw earlier today was a recurrent theme in this conference room. The other way we're looking to reduce our emissions is through load shifting. So this is called carbon intelligent load shifting, where we shift our workloads or our applications to times of the day when the wind is blowing and when the sun is shining. In this way, we can maximize our use of clean energy and reduce our use of carbon intensive energy. We've taken this one step further, this load shifting, where we can shift load across data centers. So we shift load between data centers to data centers that have more access to clean energy at the times they have more access to clean energy. Scope 3 emissions, as everybody mentioned before me, is something that's very complex. It's because we depend on our suppliers and our partners to reduce their emissions. This is a space that Google has been working a lot, and supplier engagement is something where we are targeting quite closely. We are encouraging our suppliers to set greenhouse gas reduction targets. We're supporting suppliers with improving their energy efficiency. We want to encourage key suppliers to develop carbon reduction roadmaps, and we're also providing supplier training. We feel really honored to be working with suppliers that have really advanced greenhouse gas reduction goals, and that is something that we are really proud of. The levers that I mentioned before can only take us so far. And so carbon removal is an advanced tech that we are focusing on. We've partnered with Frontier that focuses on various carbon removal technologies like direct air capture, removals with basalt that's spread on farmlands, et cetera, and then biogenic carbon removal. So how do we advance net zero technology? It's creating partnerships and collaborations with researchers, Setting up demonstrations, because we need to prove that these technologies are going to get us where we want to. And then commercializing first-of-a-kind technologies. We want to unlock innovative solutions that help both Google and the planet. Google's emissions are small compared to worldwide emissions, less than 1% of global emissions. But we believe that utilizing our technology, we can help the rest of the world decarbonize the rest of the 99%. Some of the technologies today that are going to get us there are expensive. They're not available at scale. And it's difficult to quantify the benefit of those technologies. But we believe technologies such as using our AI to do advanced flood forecasting, where we can provide notifications to people on imminent floods, or using eco-friendly routes, or giving consumers insights on the carbon intensity of the flights they use, at areas where we can potentially support decarbonization of the broader economy.
Right. So we're running a little behind schedule. I think we're going to skip the roundtable discussion and jump straight to audience Q&A. I want to thank our panel members again. It's really fantastic. We've got about, let's say, 5 minutes left. So 2 minutes says the says the sign. So yeah, questions from the audience. Perfect. Oh, you're giving the microphone.
Hi, I'm Richard Hart from ACEEE. I guess I was going to ask you the question, do you think that the administration's incredible focus through the IRA and the bill and all those things that we've seen recently have had any impact on the work that you do?
And I'm sorry, you were saying the administration, and you said
the IRA.
Tax incentives, 45 and 48, various things that have been going on in the past couple of years have been intended to promote all of the different activities that we've been talking about, and have they worked?
So I can't answer specifically because I don't know that we've been, I don't know that I have any data from when the initiatives first rolled out, but I can say that, again, the first thing that we do when we're doing our research is going out into the private sector and looking at what has progressed in terms of what materials are available. So I would say a general yes to that, for the simple fact that we are all sitting in this room, and I have looked to, attended Green Building and some of those other events, and you look at what the commercial sector is focusing on, and I have seen a shift over the past, I would say decade or so, a significant shift, yes.
I'll maybe add to that. I actually think, so that's an example of the carrot approach, where there's a lot of incentives out there for privatization and using it. I would actually argue that the stick approach has been much more effective, with regulatory requirements coming from California or European requirements that are mandating a reduction, at least in my industry, that has provided the shift that's needed to decarbonize more so than financial incentives have, unfortunately.
All right, we got another question there. And then that will be the last one, unfortunately.
Yeah, I have kind of a deep down in the weeds question. In terms of quantification, we've talked some about some of the issues of life cycle inventory, just understanding the flows and so on. Question I have is about impact calculation and bio-based materials. And I know that I'm getting an EPD from Europe using the CML impact method, and it shows that it sequesters carbon because it's using plant-based materials. And I know that in the Tracy system, which is the standard in the United States, I cannot show that. And I've heard that there's reasons why, but I just wanted to, we feel kind of stymied in some of our material supply chains on the ability to have them even be able to count what they're doing.
Is anybody all right? They're pointing. Yeah, but carbon accounting for biogenic materials is just such a mess. Like you've hit the nail on the head. And depending on how you account for like forest products, you might account for some avoided emissions associated with like sustainable like forest thinning operations, or you might account for net emissions. And so, yeah, there needs to be consistency. I don't know if we could get everybody to agree, but if you can have a few parts of the industry like lead by example and get enough people sort of coalesced behind one strategy for doing this accounting, I think that's like carbon accounting is like a thing that's separate from LCA but feeds into it is really, really important. So, it's a huge problem. Great question.
I'll just add on to that. This will be more of a non-answer, but it will be my answer. This idea of standardization at large is a huge problem. And I think that's the root of all of this, whether we're talking about carbon factors or impact factors or what have you. In my world, the analysis period for how long a car lasts, does anybody know? I don't, because everybody uses something different. And that is a huge variable and gives you a totally different number. But we can't even align on that. And so I spend a lot of my time trying to figure out how do I standardize just within the automotive industry on very simple variables. And so that's my non-answer is it's a shared problem. The solution path obviously is hard and arduous.
Well, let's thank our panel members again.